Hello, Mr. Melo here, online math teacher. Welcome to my channel. Today we're going to be continuing my video series on trigonometry, and in particular, looking at how we can solve triangles using the law of cosines. So if you find this video helpful, consider hitting the like button and subscribing, and let's go. So, what does the law of cosines tell us at a quick glance? It tells us that if you have a triangle ABC where I've labeled the angles A, B, and C and their opposite side lengths little a, little b, or little c, then I have the following relationship between the side lengths and the angles. So if you notice, it kind of looks like the Pythagorean theorem, but with a little bit extra, because not all triangles are right triangles. And in fact, the only reason we really teach the law of cosines is so you can get your hands on solving non-right triangles. Because it would be hard to just stick to the Pythagorean theorem and right triangle trig to solve it. So we want to see how we can use this law of cosines to solve problems. And there's going to be two different cases of problems that we're going to look at. The first one is what happens if you have an SAS triangle. So if I have triangle ABC with side lengths A and equal to 55, C equal to 51, and angle B equal 124, how can we solve this? Now, it's always good if you can draw pictures to scale, but I always tell my students first, don't worry too much about drawing to scale. Focus on draw and label a picture with the angles and the sides first. Don't necessarily focus on them being to scale. So I have triangle ABC here, and I've labeled the opposite sides with the lowercase versions of the letters. And when I do this, I might now fill in what I'm given in a different color just to help emphasize. I was given side length A is equal to 55, side length C is equal to 51, and angle B is equal to 124 degrees. So this is what I would start with. Now, how would you know that this is a law of cosines problem if I didn't tell you? Well, you're either usually using the law of cosines or law of sines to solve the problem. Whenever you can't start off by knowing a side length and its opposite angle, well, you will have to use the law of cosines to start. So I don't have a side length and an opposite angle anywhere here that I can figure out quickly. So this has to be a law of cosine problem. And since I was given angle B in this problem, I'm going to use the version of the law of cosines that has cosine of angle B in it to start. So I have b squared is equal to a squared plus c squared minus 2ac cosine b. That means, since I know angle B, side length A, and side length C, I'm going to start by solving for the missing side length B here. So I have what b squared is equal to. Taking the square root of both sides will give me b. And since many of the problems with the law of sines and cosines that you'll use in your class, you'll have a calculator for, I recommend just plugging this entire thing inside a square root. Don't worry about trying to simplify what's underneath the radical here first. I find that when students do that, they tend to make algebra errors. Somehow, these terms with the 55 squared plus 51 squared end up subtracting the 2 times 55 times 51. You forget that you can't just subtract because there's a cosine attached to it. So just plug the whole thing into your calculator to give you about 93.611. So now we've gotten our first side length. And now that we have that, we know an angle and its opposite side length. We know both angle B and side length B. So that means you are going to be able to set up an equation with the law of sines. And that equation is going to start with a sine of angle B, so sine of 124 degrees, divided by side length B, 93.661. Now, do you want to solve for angle A or angle C first? Well, when you are solving angles with the law of sines, always try to solve for the smaller angle first. Sometimes it's not going to matter, but a lot of the times it might, and it has to do with a quirk in the proof of the law of sines. So always just solve for the small angles when you're solving with the law of sines. So since 51 is smaller than 55, angle C, which is opposite to 50, our side length C, of 51 is going to be smaller than angle A, which is opposite the larger side length. So I'm going to solve for angle C, so I'm going to write sine of angle C divided by side length C is 51. I need to isolate sine of C if I want to solve for angle C. So sine of C is going to be equal to 51 times sine of 124 degrees over 93.661. And to get at my angle C inside, I need to use my inverse trig. I'm going to apply inverse sine to both sides of my equality to give me sine inverse of 51 times sine of 124 degrees divided by 93.661 should be equal to angle C. And you'll just plug this into your calculator if your teacher gives you one to get angle C being approximately 26.835 degrees. So I'll go up to my picture here and write in a 26.835 degrees. All that's missing in the picture now is angle A, and you know two of your other angles in the triangle. So since the angles always have to add up to 180 degrees in a triangle, we can just find angle A by subtracting off the other two angles that you've solved for. And this will give you angle A being equal to 29.165 degrees. So I'll write that in my picture up here, 29.165 degrees. So this would be an example of how you might solve an SAS triangle with the law of cosines. So what's the other type of problem you'd solve with the law of cosines? That's going to be an SSS triangle, so you know all your side lengths of the triangle. So in this case, I know A, B, and C. So my students would start by drawing a triangle, not necessarily to scale for me, and then labeling in that they know side length A is 5, side length B is 4.5, and side length C is 2.5. And then they'd ask, what do I need to solve for first? Well, again, you would know this is a law of cosines problem because there's not an angle and its opposite side length you know. So you definitely can't set up the law of sines. So it's definitely law of cosines. But which version of the law of cosines do we want? We could try to solve for any of these angles. Well, typically when you're solving with angles with the law of cosines, you always want to solve for the largest angle with the law of cosines. So the opposite of the law of sines. Sines, small. Law of sines, solve for the smallest angle. Law of cosines, you'll solve for the biggest angle. So since side length A at 5 is the largest side length, the angle opposite angle A is going to be the largest angle. So I'm going to use the following version of the law of cosine. A squared is equal to B squared plus C squared minus 2BC cosine of A. So I'll plug in what I know. And again, if you want to solve for angle A, we need to isolate cosine of angle A first. So I'm going to rearrange to do just that. So you see what I have on the right here. And again, just like before, I encourage my students not to do the algebra out ahead of time. I find when they try to do the algebra in the first step to simplify those numbers, they end up inevitably making a lot of mistakes. They'll combine things that can't be combined. So once I'm here, I just apply inverse cosine to both sides of my equation. And I just plug the whole thing on the right into cosine inverse. When I go to solve this, you could try to simplify if you want at the spot. Students tend to be good about not making mistakes here. They make them beforehand. But when you do this, you will get that angle A is about 86.177 degrees. So I've labeled that in my picture. Now, the law of cosines is always trickier to work with than the law of sines. Not solving necessarily triangles, but the formula itself. So whenever you can then revert back to using the law of sines, you're going to do that. So we have an angle and its opposite side length we know now with A. So we're going to use the law of sines and the fact that we now know sine of angle A, so 86.177 degrees, divided by side length A. And just like in the last example, we're now at a crossroads. Do you want to solve for angle B or angle C? with the law of sines, you're going to solve for the small angle always. So sines small. So since 2.5 is less than 4.5, angle C is going to be less than angle B. So we're going to solve for angle C in this problem. So again, you got to get sine by itself if we want to solve for the angle. So we're going to isolate sine of C. And then we are going to apply inverse sine to both sides of our equation and plug this value on our right into our calculator to get an angle of 29.926 degrees, which I'll draw up in my triangle, meaning we only have angle B left. But as always, now that we know 2 of our 3 angles, we can subtract them off of 180 to find our third angle. So we will have that angle B is just 180 degrees minus that 86.177 minus the 29.926 to leave us with 63.897 degrees, which I will put up in my triangle here. And with that, I've solved the whole triangle. So these are the 2 types of problems you might have to solve with the law of cosines. So I hope you found this video helpful. If you did, hit the like button and have an awesome day.